that topic. And when you are going into AI or ML or DL, there are two types, especially this entire AI or ML is divided, or intelligence, or I can say, intelligence is divided into two types. The very first type, now, when you are trying to learn ML, the entire ML is focused on the very first type of intelligence. So we are calling it as discriminative models. So what is that? The very first type is called as discriminative models. So now, whenever you are learning all the machine learning algorithms, like if anyone is trying to learn linear regression, or if anyone is learning logistic regression, or if anyone is learning decision trees, or even if someone is learning computer vision, or we call it as image recognition. So based on the image, I'm trying to say this is cat or a dog, or I'm trying to use NLU, natural language understanding. So we are calling natural language understanding. Even this is also a part of discriminative models. So decision tree, we got k nearest neighbors, or we got support vector machines. These are all different types of algorithms. All this falls into a discriminative model. Can anyone guess what is a discriminative model? Any guess what is meant by a discriminative model? Or structured data. All right. So let me show you a small example so you may find it more relevant. So meanwhile, some more guesses. I got it from Chinmay. Some more guesses. What is meant by a discriminative model? Difference between. All right. I can agree with you, Rohit. Now, yes. So now discriminative models are more like this. Now we are trying to build an algorithm. We are trying to pass input data and we are trying to provide an output. So it is trying to say yes or no. It is trying to discriminate it. It is trying to classify apple over the ball, or it is trying to classify cancer patients over a no cancer patients, or it is trying to classify, hey, whatever the text you are writing, it is happy, or whatever the text you are writing, it is sad, or whatever the text you are writing, it is what is that? It is authoritative. So all this can be discriminative. So all these years, so we can say till like 2023, most of the work, everyone around AI, they worked on discriminative. So now, and after discriminative, now what these people done is like they started working on another set of division. We are calling it as generative models. So we have generative models from a very long time. What exactly generative models are? If we are able to provide one part of the data, if you are able to provide one part of the data, we can generate another part of the data. What we can do, we can generate another part of the data. So we are able to call it as generative model. So we have generative models from a very long time. It's nothing like a new area we are trying to work on. Generative models are there in the industry from a very long time. Can anyone give me an example of generative model? There is a name for generative model as well. We can call it as one name, generative models. Meanwhile, generative models can be called as one name I'm giving. Not chat GPT Lagna. There is another one, not LLMs. No, not image creation, not really. Now there is generative models falls into a category called as auto-regressive models. So what are these models called as? Auto-regressive. So if you are giving one part of the data, based on the current data, they are able to generate other parts of the data. Example of the oldest friend of our auto-regressive models are forecasting techniques. So we are able to take our structured data. We are able to take our sales data of last 10 days or last 1 month or last 1 year. We are able to estimate, then saying estimate, we are able to generate the data for the next 1 month, or we are able to generate the data for the next 2 months or for the next 1 quarter. So we are calling it as what? Generative models. So now generative models, the oldest friend is auto-regressive models. They are able to collect our existing data and we are able to generate them. So one of our friend is forecasting. Now, this forecasting, whatever we are doing, it is purely on a tabular data. We are doing it purely on a tabular data. There is nothing like unstructured data like images, or there is nothing like a video, there is nothing like a audio, or there is nothing like a text. So we are trying to generate the data with the help of our regular, what is that? tabular data, we are doing it. Now, even the discriminative model side, so you have a tabular data, we are able to use discriminative models for tabular models. For example, tabular data. If you are going with tabular data, I can use algorithms like linear regression, or I can use algorithms like logistic regression, or I can use a decision tree, or I can use random forest, or I can use gradient boosting. In this way, we have different set of algorithms, or I can use Navy Bayes, or I can use K nearest neighbors, or I can use support vector machines, or I can use extra gradient boosting, or I can use a cat boost. So, or I can use, what is that, ADA boost, any type of algorithms, I can take it, I can perform discrimination. I can say yes or no, there is a cancer or there is no cancer. Within this discriminative models, again, you have categories like regression model or a classification model. And below this tabular data, again, if I go with tabular, it's not tabular. If there is a text data, mostly if you have a text data, in order to translate your text data into your tabular data, we are trying to use an approach called as NLP. What is this NLP? Natural language processing. I'll be doing that, Manoj, in the last. I'll be doing it. Yeah. Natural language processing. So by using this natural language processing, what we are able to do, we are trying to convert your unstructured data, whatever the text data we have, we are trying to convert that into a tabular data. We are converting that into a tabular data, or we are calling that approach as embedding in lines of your text. Again, after that also what you are doing, you are trying to apply any of these above algorithms. You are trying to apply any of these algorithms and you are trying to perform again discrimination. All right. For example, if you are having images, I have an image data. In order to handle an image data, either you are able to use above ML algorithms. So image can be converted into a matrix and you are able to use above algorithms, or you are able to use convolution neural networks, which is a branch of deep learning. So by using this convolution neural networks, which is a branch of deep learning, I'm able to again perform the discrimination with the help of CNN algorithms. I can perform it and not really can't. So now, for example, I'm having a lot of language. I need to understand the emotions. I need to understand the sequence of words. I need to understand whatever the language someone is speaking, what exactly that language is. Again, I can take text. I can take text data. I can make my algorithms to understand every word, every placements called as parts of speech of the sentence. I can understand the entities within the sentence. I can understand the dependency words. So within your sentence, I can understand what is that co-references within the sentence. I can do all this understanding. We call it as NLU, natural language understanding. I can do it with the help of an algorithm called as LSTMs, which is also a part of deep learning. These are all discriminations. Now people got an idea. So like we are able to take this image and we are able to discriminate it. Now, is there a way that I can generate the particular data? The very first stage of generating your text data started with the algorithm called as, if you are going with vision-based generative models, or I can say generative AI, vision-based generative AI, the very first algorithms comes into autoencoders. So what autoencoders can do, they can decompress the image and they can again expand the image. So most of iPhones and all that, for a very long time, they use this vision-based generative AI. If you take an image, even Google Pixel, not only autoencoders, there are varieties of it. So we got autoencoders types, we got GANs, generative adversarial networks. So we got diffusion models recently. We got neural style transfers. What are neural style transfers are? We are able to change the background of the images. Neural style transfer. In this way, we got various varieties of our vision-based generative AI models. Now, the very olden approaches are, we are able to take an image, even if it is a blurred image, we are able to convert into a HD image with the help of this vision-based generative AI. Now, we are able to take, again, what is that? We are able to take our, the regular, if someone is taking an image, we can increase the quality of an image someone is taking within the phone. Even though the camera pixels are very low, we can do that. Even if someone is taking an image, we can make that image more like a photo, means like some at a quality of a photographer. So with the help of this vision-based generative AI. But the major problem with the vision-based generative AI is, now if I'm giving an image, what exactly the one part of the data? If I'm giving image as the input, it can convert again image as the output, or it can generate an image as the output. So it can understand the image, but if I'm giving text as an input, it is unable to convert that text into an image form. It cannot be done. That is one of the major, we can say, backlog, or one of the limitation of this vision-based generative AI in the very olden days. So now what exactly the current models are, before, in order to explain about the current generative AI, then we got another one. Another simple one, we can call it as a text-based generative AI. So how many of you remember translation in the very olden days? Is it good or bad? The translation from one language to another language, or the subtitles, are they good or they bad? The subtitles, are they good or they bad? What do you say? Subtitles by your YouTube and all that. Is it good or is it bad? It's good right now. What about in the olden days? When you're going back to olden days, what about it? In the olden days, it's pretty nonsense. Now, what exactly improved? In order to explain about all the stages of our text-based generative AI, let me start with the initial algorithm which used for text-based generative AI. Now, I said LSTMs here. LSTMs are used in order to discriminate your text data. In order to understand your text data better, they started using LSTMs. Now they started piling up multiple LSTMs. So one set of LSTMs are used in order to encode your text data, means like in order to understand it. Another set of LSTMs are used in order to decode it. Example, language translation. One set of LSTMs are used in order to encode your English into some other encoded information. From that encoded information, we are decoding with another LSTMs into Hindi language, or into Bengali, or into Marathi. In this way, we are doing it. Now, the very initial based algorithm, we call it as encoder decoder models. Very initial models. They are not good. They are very much, what is that, straightforward. What do you mean by straightforward? While they are encoding, so like Rama, they are only looking at Rama and they are decoding Rama. While they are encoding Rama is a good person, they are looking at only is and they are trying to decode is. While they are encoding good, they are trying to decode only good. But when you're looking at the overall language, now in order to translate one to the another, do you need to understand the overall context of the sentence and do you need to translate it? Or one word to the one word is a very good approach. Translating one word to the exact one word, is it a good approach or it's a wrong approach? Which is good? One word to one word, or understanding the overall context and translating? So understanding the overall context and translating is one of the best approach. That's where encoder decoder models are failed. For that reason, what they have done, they started developing another algorithm called as attention based models. They started developing attention based models. What are these attention based models are? They are trying to translate one word. So while they are translating Rama, it is giving more importance to Rama and it is translating. While it is translating is, it is trying to give more importance to is and it is trying to translate. And while we are giving an importance to good, it is trying to give more importance to good and it is trying to translate. But even though it's not that big hit, so in order to overcome this approach, hey, how exactly we are able to get a breakthrough? So how can we get a very good amount of performance? So in order to do that, they started releasing one research paper. So in 2017 by Google, we call it as Attention is All You Need. We call it as Transformers research paper. They released the very first research paper, which we are calling it as Transformers research paper. What exactly is there inside the Transformers research paper is the very simple concept. This is the image. What exactly is this? Now, each word, now, for example, I arrived at the, for example, maybe it can have a very lengthy sentence, but each word is trying to communicate with another word. So now what exactly each word is doing? Each word is trying to communicate with other words in order to understand about its own self in a better way. So what exactly these transformers are doing? What is the idea behind transformers? So now whatever attention based models you said, or whatever encoder decoder you said, so they are not that good. So now each word can communicate with other words so that it can understand about itself better. Now I is trying trying to communicate with arrived, at, the, and various words, and it is trying to know about itself in a better way. That is the very initial point of your transformer models. So with the help of this, how exactly this transformer model is going to understand one word with the another word is with the help of a very simple math. I'm not touching math. Shall I show you that equation? So am I going deep or you are able to get it? Are you getting it? Shall I go a bit able to understand, by the way, before that, or you are, it seems like Greek and Latin? So let me show you the equation. So now based on that, so we are calling that equation as self-attention equation. So now this is your self-attention equation. While we are learning about deep learning, you are able to know more about it. So no need to worry right now. But this is called as an equation. So this Q is called as a query vector, key vector, and a value vector. So by using this, this is called as self-attention mechanism. There is a concept called as multi-head attention, and there is a masked multi-head attention. These are the two different mathematical concepts which we have it. Now, based on this mathematical equation, each word is able to communicate with another word, and it is able to understand about itself in a better way. So we are calling it as what? Context. Now, let me show you a small example. Let me just go to here, and I'm asking, I want to buy Apple. Instead of saying shares, I just give an example. I want to buy Apple. So when I gave I want to buy Apple, what exactly the search it gave? First one it gave me based on search engine optimization. You're able to get the first one, Apple. Most of the results are related to I want to buy the Apple company, how to buy Apple shares, how to buy iPhone, premium reseller. Now on the another side, 1 minute. Now on the another side, look at this. I want to buy Apple. When I gave I want to buy Apple, again it started giving me about if you are looking to buy Apple product. So I want to buy, for example, maybe I want to buy an apple, for example. If I want to buy an apple, again the same thing. I'm changing the keyword. I want to buy an apple. Now see, just by changing one word, what happened? Just by changing one word, instead of apple, I just said an apple. Now what happened? It is giving the results about fruit, or it's giving about a company? It is giving the results about fruit or a company now. The second answer. It is trying to give the results about a fruit. And when I'm just said buy Apple, now it is trying to give me about the overall thing. But if I go back to the Google, it is still giving me about all the search engine results are about what? Apple. So the same Apple phone itself, it's not about the fruit. Now the difference between search engine, Google search engine, and your chat GPT is search engine works on the keywords. So it just care about Apple keyword, it care about buy, it care about what. It is not looking at entire sentence as a sentence. It is trying to look at this entire sentence as the tokens. We call it as tokens. So each then saying like each word, I want to say the combination of 4 characters. So I space WA. So this 4 things going to be taken as your token. So like based on each token, it is trying to it is trying to just take the tokenization based on the tokens. It is trying to give the highest repeated token documentation on the top. So in order to get a SEO, that is a very simple trick. You need to have that particular keyword most repeated in your website. The very simple fundamental. Now ChatGPT is trying to understand the context. How ChatGPT is understanding the context? With the help of a simple concept called as self-attention mechanism. Perfect. This is a very simple idea. Now, based on this research paper, now based on this model architecture, 2 different types of algorithms came into the picture. Because of this transformer model architecture, 2 different types of models. After attention based, we got another one called as transformers. That's the breakthrough. By using this transformer models, we got 2 different algorithms or two different companies or two different approaches came into the picture. One are called as auto-regressive models. Another one is called as auto-encoding models. The very first model, auto-regressive, which is called as, if you are giving one part of the text, we are able to generate another part of the text data. And the very first company who started auto-regressive models are GPT models. So OpenAI started doing a research on auto-regressive models and they started releasing GPT. And after that, we got different versions. And from GPT version 3, there is a very big boom. And there is another one called as auto-encoding models. What this auto-encoding models can do, we call it as BERT models. If I'm able to close a particular word, it is able to complete it. So it's more like a fill in the blanks. If I'm saying Rama dash person, it is able to say good. So we call auto encoding models. So it is trying to understand the overall context of the sentence, and based on that, it is trying to complete a particular word. It is trying to complete a particular thing. We call auto encoding. But what is auto regressive is based on the certain context of the data, it is able to generate another sequential length of your data. So by using your self-attention mechanism, it is able to understand about its words better, and it is able to start generating the future words. How exactly they are able to generate future words? Now, you saw about discriminative models and you saw about generative models. And now I want to go with another in-depth concept within this discriminative models and generative models. We got another two different types of categories. So what are they? Able to understand, right? Within this generative and discriminative, we got another two categories. One is all our ML falls into, yes, it is a discriminative, and within generative, again, we have two different categories. Can anyone guess? Within your ML, we have again, within this generative models and discriminative models, we have again two different categories. The name starts with P and D. And even in SQL also, sometimes we use it. I call it as types of models. I'm calling types of models. There are two different types of models. The very first type of model is deterministic model. So we call it as deterministic model. So what exactly meant by deterministic model? For a fixed input, you are able to get a fixed output. For a fixed input, you are getting a fixed output. Example, I want to buy an apple. Again, let me copy this and let me paste it and run. I want to buy an apple. You are looking to buy a fruit. Now see, from the above to below, is it same or different? For the same question, you are getting the same answer or you are getting a different answer? For the same question or for the same input, are you getting the same output or a different output? You are getting a different output. So then it may not be deterministic. The reason why it cannot be deterministic, what is a deterministic model? For a fixed input, if you are able to get a fixed output, example, A equal to 3 and B equal to 4. So if I substitute into A square plus B square plus 2AB, do I get the same output every time? Do I get the same output every time? For the same input, do I get the same output? Obviously. So we call it as deterministic models. And now if you look at ChatGPT, it is not a deterministic model. Is it a deterministic model? If you take ML, now for a fixed input, do you get the same output every time? For a fixed input, if you are fixing your sample, if you are fixing your random state and all that, do you get the same accuracy or different accuracies different times? Same algorithm, same random state, and everything is same. So like you will be getting same accuracies or different accuracies? Mostly. So like out of 100%, I can say most of the time, I think 98% most of the time, it would be the same answer. So I can call it as deterministic. Now, what are these generative models are? They are not deterministic. They are probabilistic. Why these models need to be probabilistic? Very simple. Now let's take humans. Now, there is a guy who is creative person. Now, when I'm giving, let's take, I'm speaking something more like a lady example. Now, there is a very good designer. I'm not saying designer, there is a Tyler first. Now, when you're going near her, you're giving one particular dress item. Every time if she's going with the same output, you may not like it. So now, who are creative people? For a same output, if they are able to come up with multiple designs, can I call them as creative? For the same output, if I'm able to get, if for the same input, if I get different outputs, can I call them as creative people? Can I call them as creative people? Yes, we can call them as a creative people. Now, generative models are creative in nature. Now, whenever you're going with any generative model, the basic fundamental idea of a generative model to be creative. So no one want, for example, very simple example. Now, if I'm giving one image, it is creating the same image. There is no purpose of your generative AI. I'm giving a blurred image. It is making HD. That's okay. There is no need to be any creative there. Now, there is like example, I'm writing one paragraph. I want it to be different versions of the same paragraph. It need to be creative. Now I'm giving one image. It need to generate some other different varieties of image. Example, I'm just asking create an image of person listening classes inside the bar on the moon or something, whatever comes to my brain. I just gave it. Now, whatever it learned in the past, it is trying to use that reference and it is trying to generate a new image form. Got it? Is it created? It created. Now, this is, I can call, hey, it's a generative AI. Why? So I'm using my, whatever the previous knowledge, that's my requirement. My goal is not just to learn about taking a blurred image, making it into HD, taking this, do it. No, 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 I don't want that. Now, there is something, the background is not good. I can select it. I can just say, replace with some other background. It need to use its creativity and it need to generate. That's what we are trying to do. Now, when you're for a same sample, for the same horse image, I don't want the same horse images. I want the different versions of horse images. So now I don't want the same text image. I want the different variations of the text I wanted. So in order to, I don't want my models to be deterministic. I want my models to be probabilistic in nature. What exactly meant by probabilistic in nature? We are able to get a distribution of a possibilities. We are able to get a distribution. Let's take a simple normal distribution. Let's say something, a normal distributed range of your, a distribution of various combinations. That's the reason I can ask generative AI to give me n number of varieties, but it may not give a lot of varieties, a fixed set of varieties. Now that's what we are doing. Even if you look at this, now see this. Within this generative AI, how each word they are trying to generate is your self-attention mechanism is used in order to understand the context of the word. And we got, based on our understanding of all the internet data it learned, now based on that, we are able to get various words available. Very simple example. Now, even humans are also more like that. Now, you watch a lot of Netflix, you watch not lot of Netflix, or you watch a lot of series, or you read a lot. And after reading, after watching a lot, your vocabulary going to be more like a Netflix guy, or it's more like that particular author who written that particular book. Have you noticed it anytime? Have you noticed that anytime? And again, if I just add a bit of confidence, so like you're speaking with a guy who is means like he don't have that knowledge, let's imagine, or he is a bit weak, or he's not that intelligent, or he may not be that intelligent than you. You will be speaking very confident. Now let's change the situation. You are trying to speak with a guy who is having a very high amount of knowledge. Then what happens? You try to be tensed. You try to pick the wrong words. Have you noticed it anytime? You try to pick the wrong words. Have you noticed it? You try to pick the less confident words, you try to pick it. Because of that, you may not pronounce it good, or your articulation may not be that wonderful. Now, because of the probability distribution, when you are asking your ChatGPT, I don't like it, can you rewrite it? It is trying to pick less probable words. What exactly your ChatGPT is doing? It is trying to pick the less probable words, it is trying to pick it. Now, that is what happening inside your ChatGPT every time. Whenever you ask a question, it is able to generate a list of probability words of a sequence And whenever you're asking to recreate it, instead of picking the high probable words, it is trying to pick the less probable words. So now when you are saying don't go with creativity, I don't want my answer to be creative, then you are able to set your answers to be deterministic in nature. What is deterministic? Every time you get the same answer, we call deterministic. We are able to fine tune them in our coding as well. We call that metric as a temperature. Let me show you that. Not ChatGPT, OpenAI. Now, if you look at this, we are able to see playground. Within the playground, able to see the parameter here, temperature. Able to see the parameter called temperature. What exactly the temperature parameter is? Controls randomness. Lower results in less random completions. As the temperature approaches zero, the model will become deterministic and repetitive. Now, when you are setting your temperature value to zero, now, what exactly happens? Example, how many leaves we have it in a company? Or for example, the ChatGPT or LLM models, we call LLMs. This LLM models are working for a particular company to give some answers. Now, every time when it is giving a Q&A, it need to be the same or it need to be different. When you're speaking for a company, it need to be same or different. It need to be mostly same. So then this temperature value need to be zero, so that for a fixed input, it's going to give the fixed set of output parameter. If you are increasing this creative temperature value, what exactly meant by temperature more? You are trying to write some what is that? YouTube titles. You are trying to write down a blog related title, or you are trying to write down, create an image, or you're working as a marketer, then you want a lot of creativity. If you want a lot of creativity, example, you're writing a code. Now you need to have, if you want to fix a code, you can have a more temperature value. No, I don't want to fix my code. I just want to give the same right answer every time, or the highest probability value need to be provided every time. Then set temperature value to zero. Now this temperature, if you are increasing your temperature, the model is trying to be more probabilistic. When your temperature is close to zero, your model is being more deterministic in nature. Now, if you take any of these models, whether you take your transformers, GPT, now these models are able to behave. What exactly they can do? They are able to be more probabilistic in nature, as well as they can be deterministic in nature. But if you go back to any of your ML algorithms, if you go back to your ML algorithms, or if you go back to your image-based algorithms, or if you go back to your LSTMs, all these are more likely to be a deterministic models. They are not probabilistic models. Now, why you need to have a probabilistic model? Example of probabilistic models are, can anyone give me real-time example of probabilistic model? Forecasting? Not really. So the real example of probabilistic, or the very first probabilistic model, is your stock market. Now, for a fixed input, every time do you get the same results in stock market? For a fixed input, do you get same results every time in a stock market, or no? People who are aware of stock market? Not really. So which is a probabilistic model. In order to work on probabilistic model, we are having initially algorithms called as Markov chains and hidden Markov chains. By using that, we are able to build probabilistic. Now, all our current models are probabilistic in nature, especially vision-based models, text-based models. They are very good at what? Your probabilistic models. They are able to generate the data. Now, in order to build any of these models, it's more like a human. So all this, when you say, generative models and all that. In order to build all this, it's impossible to build it with ML. We are trying to build it with the help of a concept called as deep learning. Let me give you the divisions of AI. I'm assuming you know this. There are three types of AI, as I say every time. Narrow AI, you got general AI, you got super AI. And within these three categories, we got narrow AI. The very first stage, we started developing narrow AI in the AI. So the very first stage, we started with neural networks. So we started developing all these neural networks and all that around 1960s to 1970s. We started developing artificial neural networks, which are similar to the human brain. And after that, we started, it's a failure. It's not that great and wonderful. So it's a big failure. And after that, we started developing ML algorithms. And ML algorithms are around 1980 to 2010. They started investing a lot of time and research into ML algorithms. And after ML, we got DL algorithms. So DL algorithms are nothing but it's a reshaping or the rearrangement of your neural networks. So we call deep learning. So initially, deep learning is a part of ML because of its huge impact. They separated deep learning as a sub branch of machine learning. And within deep learning algorithms, so now from 2010 till now, present, it's all research happening on deep learning. So within this deep learning, so if I want to do generative models within machine learning, we are able to do it with the help of forecasting. If I want to develop probabilistic models within ML kind of approaches, we are able to use Markov chains. By using Markov chains or by using hidden Markov chains, we are able to generate probabilistic models. Now, within deep learning algorithms, I can perform like all these probabilistic models and deterministic models. If I want to perform generative models, I can use the below algorithms: LSTMs, autoencoders, GANs, diffusion, transformers. All this falls into a category of your deep learning algorithms. So why deep learning algorithms are? Deep learning algorithms are more like humans. Now, each deep learning algorithm, the current models, going to contain closely around 300. If you take llama models and all that, they are saying like 405 billion parameters. Llama models are 405 billion. There are 300 billion parameter models. What are 300 billion parameter models are? If you are okay, shall I explain it or no need to go that deep? Shall I explain that part? What are these parameters? So I will be just giving it in simple way. Now, it's a very big, lengthy topic. It would be too heavy. But to make it more easy, I'll be just trying to explain it in a very simple example. Now, when you are going with the regular ML, you have an equation. When you are going with your regular machine learning, you got an equation y equal to mx plus b. Now, this m and b, the unknown parameters inside this equation is m value and a b value. Now, this linear regression equation contains two parameters. This equation contains two parameters. And in order to identify the right m value and to identify the right b value, we got an equation called as OLS, ordinary least square, or we are able to do it with gradient descent, or we are able to do it with a straight line technique. By using any of these three approaches, I'm able to identify the values of unknown parameters, m value and a b value. Now, there are how many parameters here? For a llama 3.1, how many parameters? Here we got two parameters. How many parameters we have here inside this llama model? There are 405 billion. It's not even million. There are 405 billion. And if it is again like a equation like linear regression, OLS equation, or a gradient descent or a straight line, I pass the data. I just compute that mathematical equations. I'm able to get all the 405 billion values. That's done. But deep learning is not like that. I need to identify this 405 billion values. Example, y equal to mx plus b. Now, I don't know, let's say I know only math. I don't know anything about this OLS gradient straight line. I said, hey man, you want to identify the right m value and a b value. where x value equal to 10, sorry, y value equal to 10, x value equal to 2. Now he don't even know proper math, he know only a difference. He started assuming it as, for example, 3 multiplied by 2 plus 6. Now if I subtract left hand side and right hand side, what is your value? When I subtract left hand side and right hand side, 3 2s are 6 plus 2. And what is the difference we are able to get? What is the difference we are getting? Minus 2 we are getting. Again, so now this is not right. Again, what I say, hey man, the difference between left hand side and right hand side need to be 0. Until the value is 0, when you're differentiating, when you're differencing from left hand side and right hand side, you are keep on changing m value and a c value. Now, just imagine without a fixed equation, until the difference is close to 0, you want to keep on changing 405 billion parameters. Is that easy or a time consuming task? Without having a fixed equation, until you get the value close to 0, you need to keep on changing 405 billion parameters. It is very time consuming, same like a human. Even humans, in order to understand a topic, now the goal is, that's the reason, if I simply, very simple, if I give you a simple rule, I'm not giving an option. If I give a rule, without deep learning or generative AI, you cannot get a job as a data scientist or AI. Now, will you be learning the skills or not? If we give it as a mandatory, will you be learning or no? If I make it compulsory, can you learn it? Yes. If I make it optional, now what you do? You don't even learn, you may not learn it. You say it is a difficult concept. Again, if I say in order to learn data science, the only way to be a data scientist is you want to learn France or French, and then you want to learn data science. All the data science going to be explained in French. Then what you do? You go back, you enroll into French classes, and then you join data science courses. The same way you do it. Now, when you are saying to your human brain, if it is mandatory, no matter what, they can learn. So they can do anything in the world. They can do anything. They can eat anything. They can live with anything. They can survive with anything. So that's the power of a human brain. Now the same concept. Now I can give anything. I can ask my LLM models or this deep learning models to create an image more like a photographer, to create a paragraph more like a professional, to create this more like this. It is able to learn it and it is able to do it. Now that is the power of your deep learning. So by using this deep learning, now what this most of the companies are doing, they are inventing everything. So now the LLMs, without deep learning, without a human kind of mechanism, this transformers may not be possible. Or whatever GPT is doing, it may not be possible. Image based may not be possible. Once they got text based and vision based, they started joining both text based and vision based, so that these models are being more multi-modals. What do you mean by multi-modals? I can pass a text data, I can ask it to generate an image. The old problem is it is unable to understand text because of understanding its own word. It is unable to understand its own context better. Why? They are taking only each word and it is trying to understand only that word. Because of transformers, they are able to understand what people are asking and it is able to generate an image better. So they started joining text-based generative models with vision-based. So they started understanding the text better. So they are able to generate a beautiful vision. That's what happening. And after, when it is started understanding text better and it is able to generate an image, now they started using multi-modals. What is that? So you can pass a text, you can input, you can pass image as an input, you can pass video as an input, you can pass audio as an input, you can pass even gestures as an input. It can understand any of this data as an input, same like a human, and it is able to generate either a text, it can generate a video, it can generate an audio, it can generate even a code, anything it can generate. We are calling them as multi-modals. Now all these are generative models. On the another side, what these people are doing, they started developing another set of models which are called as, within these models, we got agents. What are these agents? So now these agents are more like your generative models. So like what these agents can do, they are able to automate the workflow. What do you mean by automating the workflow? They are more task oriented. What is meant by task oriented? if I just ask my generative model, if I go back to this, if I go back to ChatGPT, if I ask, write a code to clean the data using Python. For example, if I just upload any of the data from my system, I'm just importing this some data set. Write a code to clean the data using Python. So what exactly this LLM is doing? First, it is trying to understand the data, multimodal. It is understanding the Excel data. It is understanding my text, which I provided. And based on that, it is already, if you notice it, it is giving a cleaned data preview. It is trying to provide me a cleaned data preview. It is not even asking me to clean. It is already cleaning it. And if I look on it, it is able to run all the commands. What are these agents are? Now, your generative model, whatever the text, I have it here. I'm feeding this Excel. I'm feeding this text data inside an LLM. It is trying to generate a code. It is trying to generate a code. So I'm taking this code, I'm feeding inside I'm running all these commands on top of my data set and I'm cleaning it. If I'm getting any error, again that error I'm feeding into LLM. Again, LLM is giving a response. Again, I'm taking that response, I'm running it. And again, if I'm getting successfully executed, I'm printing the output. In case no any errors, again, I'm passing that inside my LLM. Until I complete a task, I keep on passing the data inside LLM and I'm finally getting a task. Now the current GPT-4 or O1, they are all agents. They are not regular generative models. What are agents? If I'm able to give a task, it is able to generate a data. It is feeding inside the environment. It is executing it and it is making sure we are completing a task. So if your entire model is focused around completing a task, we are calling them as what? Agents. So now when you are saying this, when they are completing task, or we can say they are completing task, we don't call it as automation, we call it as autonomy. So what exactly agents are doing? They are trying to perform autonomy. What exactly meant by autonomy is, now there is automation and autonomy. So in an automation, so now you are using a combination of human involvement plus a machine involvement, but in an autonomy, you are not using any of the human involvement. So now what agents are doing, they are trying to, LLM model is giving it output, it is automatically running it without even taking the intervention of a human. So we are calling it as autonomy. So now agents are not that great. So like they are at a very initial stage of it. So now, this is a one simple example of what? Autonomy. Got it? Is it clear? Able to get it? Sorry. Able to get it? Automation versus autonomy. Now, companies are more interested. Now, why? The lot of jobs are coming into the picture. Very simple. Now, with the help of generative models. So now what companies are doing? If I want to do recruitment, now we are developing one product for HR development, we are developing a product. And we are developing another product for this one, manufacturing. We are working on chemical plants. And for that, we are developing one small product. And apart from it, we are working on manufacturing plants. We are developing regular computer vision based models. Now, most of the companies, they are already familiar with all the machine learning. Now, again, there are two different types of job roles you need to keep into the picture. Now, I say this. Now, there are two different job roles, or I can say job roles. Then I don't want to say job roles. I want to say project types. I want to give it as a project type in a real time. The very first type of project is analytic project. Analytics. I call it as analytics. What is the role of analytics is? Now you all know you are trying to take Power BI or you take SQL, you take Python, you try to share some insights or KPIs to the clients. They're able to understand about their business. So in order to make various business decisions, or I can call it as informed decisions, or I can call it as data-driven decisions, informed, any name, business decisions, I can use especially Power BI or SQL or Python, or I can use even ML, machine learning, in order to perform business decisions. So I call predictions. And one purpose of doing this is, so every company needs this machine learning and all that. Yes. So these projects are common and they happen. Now there is a guy who make every decision. For example, there is AB and Bev, where exactly our students are working. Now they use machine learning in order to estimate the demand of different beards. So based on that, they can manufacture them. And that is one. Again, they are working on invoicing in order to see or identify the duplicate invoicing. They are using machine learning. Again, duplicate invoicing may not be analytics. It falls into a category of automation. Now, every company, when they are having ML as a part, they try to use analytic projects and there are automation projects. If I'm trying to understand the demand of my beards, it is a business decision. I can call it as analytics. For that demand of it, I use machine learning, especially forecasting. And I want to identify a duplicate invoices and I want to cancel the duplicate invoices. Why? I want to hire a human in order to check the duplicate invoices. Instead of that, I want to use a human. Sorry, I want to use an AI, or I want to identify the mistakes in an invoice. So duplicate invoices or mistakes in an invoice. In order to do that, I'm using computer vision. Now that is an automation. So I'm using deep learning. Or I want to use automation for the sake of a chatbot where I don't want a regular chatbot. I want a human specific chatbot. Example, I don't know whether you saw it or not. Fractal Gen AI. It's a fractal analytics. One minute. His name is, 1 minute. There is a guy within Fractal. They developed one chatbot. MarshallGoldsmith.ai. So yes, MarshallGoldsmith.ai. Yeah, this guy. So now they developed a LLM model. So like it's not an they haven't developed an LLM model practically. So they performed they done prompt engineering, or it can be a RAG architecture mostly. They used RAG architecture or prompt engineering. So for this means like for this guy. So like if they're asking any questions with this LLM, it's going to speak more like this Goldsmith guy or this Marshall Goldsmith person. That's what they developed another one. Now, this is another LLM automation which they worked on. Now, this is again a chatbot. Now, the chatbots, I don't want a chatbot to be a regular boring chatbot. I want a generative AI based chatbot, and it need to be customized to our company. For example, it need to be customized to Kant, or it need to be customized to you people. I'm not asking you to build an LLM chat GPT. I'm not asking you to build that. Why? If I want to build it, you want to have this exhaustive knowledge and you need to develop everything from scratch. You need to have it in order to get into a job. You need to have it. That's important. But we are not developing it. The reason, it is very expensive. And if I want to build this kind of models in a company, just imagine like Marshall Goldsmith, can he invest 60 to 70 crore rupee to build a model, to build a chatbot? 60 to 70 crore rupee only on infrastructure, without paying data scientist salary, without paying AI engineer salary, just only for an infrastructure. Can he invest 60 to 70 crore? No one going to do that. For that reason, what they are doing, they are trying to take the big companies, like they are trying to take models from OpenAI, or they are trying to take models from Facebook, or they are trying to take models from Anthropic, or they are trying to take models from Mistral Labs. They are taking models from various companies, and they are trying to customize them to a company requirement. So we are calling them as, if I want to build a generative model or a chat GPT from scratch, I need to have the knowledge of deep learning. I need to have the knowledge of neural networks and all that. If I want to build a chatbot completely customizable for a company, so I can use approach called as transfer learning. By using this transfer learning approach, now I can customize it based on a technique called as prompt engineering. Within prompt engineering, we got prompt templates, we got again types of learning, zero shot learning, few shot learning, we call types of prawns or types of learning. By using them, we are able to make our models to learn it. Now, whatever we are doing within ChatGPT is a zero shot learning. What do you mean by zero shot? I'm not giving any example. I'm just asking a question. It is responding. Zero shot learning. There are ways of giving that example. I can go with single shot. I can give an example. I want my answer to look like this. So we can do with that. Or there is another example. Another one is called as, for example, one of the case study we have it within bookings.com, or even within various companies are using RAG implementation. Mostly bookings.com, they are implementing RAG, and even various bank people are also implementing RAG. Very simple is that. Now, all your bank data, can I use it for training a model? Your bank transactions, your failure transactions, all this, can I use it to train an LLM model? To train it, or can I give it to OpenAI or Facebook to see, go through your banking data, account information and all that? Not really. That is a data breach. That is a very big crime that's going to happen. Now, what we can do, we are able to, so now when someone is going and asking an LLM, so now here chatbot, whenever I'm going and asking an LLM, it should not use its internal knowledge. It need to use an external source. Now, what is prompt engineering is, you are not changing your chatbot's knowledge. You are trying to change the output based on the way you are trying to guide it. Very simple example. There is a kid. I'm asking him, hey man, go and do that work. Hey, go and do the homework. He may not do that. If I'm asking, you are a very good person. You are a very big boy. So like, I think you don't skip your homeworks. Is that right? So like, then what exactly this person going to do? He going to feel it, hey, I'm a very big boy. I don't want to miss my homeworks. I want to do it. So the way you are trying to explain, or the way you are trying to articulate your words, the expressions, the emotion you are carrying, the tone you are maintaining, based on that, a person output going to change. That's what I'm calling in simple prompt engineering. Now, what exactly your RAG is? So now what exactly RAG architecture is? Now I'm not changing the intelligence. Again, the same chatbot. Instead of saying chatbot, I'm saying LLM, or I can say GPT, any name. I'm giving LLM. Now, when someone is asking a question to LLM, it is not using its knowledge. Instead of that, it is trying to look at external document or external database. It is trying to look at external database. I'm asking a question, can you tell me number of leaves? Or I'm just asking, can you tell me the reviews of this particular hotel? Then what exactly LLM is doing? It is looking at the external source of bookings.com, related reviews, related their hotels. It is looking at that, and it is trying to give a response to the user. It is not just giving a generic response from the internet data. It is trying to give a response from the data provided by bookings.com. Now, example. So like, there is already RAG architecture, which is available. We call it as, what is that? Coral.ai. It is called Coral.ai. Mm-hmm. Not this. This is Coral AI. I'm just picking any of the material, let's say advanced deep learning material. I can't actually remember all that. Let's imagine. I'm just open, upload. And again, there is a scan document. If there is a scan, in order to extract the text from a scan document, we got a concept called OCR, optical character recognition, which is developed using computer vision. And again, it's all combination. It's not one technique we are using right now. We are using various techniques in one package so that we are able to do a lot. And once it is done, man, yeah. Now I got it. I can start. I'm just asking, explain the math behind CNN algorithm. When I'm just running it, now it is trying to explain all this from the Word document which I uploaded. And it is giving me the references. Now, this is more like a RAG architecture. So now why? I don't believe the knowledge of RNNs. I'm believing the knowledge of my, what is that? I'm believing the knowledge of my PowerPoint presentation, which I have it, or the document which I have it. So this is by Kant. So I'm uploading that presentation. And from that, I'm trying to ask it to summarize. I'm trying to ask it to, hey, can you explain with simple example? So I'm just asking it to summarize. So it is trying to understand from my document, it is trying to summarize it. So that it's going to be more easy. We can feed any type of data, mostly Coral.ai. It's mostly for PDFs and Word documents. I haven't tested it for CSV. You can test it. So this is a free one. You can use it. Mostly companies are using it for reading research papers. Now, if I want to read a big research paper, I cannot sit and read all the research paper. The PhD people, they use this Coral AI. They upload the research papers and they're trying to summarize it and they are trying to write a research paper on top of it. Now, this is more like a RAG architecture. Instead of using my internet data, I'm using RAG layer. This is also another project most of the people are trying to work. And what even they are doing, apart from RAG, apart from this one, prompt engineering, they are trying to work on creating small agents. We can create Python agent. We can create SQL agents. So agents are like we can develop them. So like ChatGPT, we are using it, we can develop them. We can develop Python agents, we can develop SQL agents, we can develop Slack agents. So automating Slack channels. So we are able to develop those agents. So agents' primary goal is to perform it. And apart from it, companies, so like most of the companies, analytical companies, apart from developing, using these models, using it is a very easy task. So instead of using it, some of the companies are trying to build the LLM models, a smaller size LLM models. We are calling them as SLMs, small language models. They are trying to develop this small language models. Now, what these people are doing is the very simple reason why data scientist is getting into this. Now, I already have analytical team who are data scientists who are working on this. Now I'm asking my data scientists to work on even automation activities. Man, why? Why the companies want to work on automation activity is one, in order to attract stakeholders. Man, everyone are speaking about generative AI. Are we doing anything around it? So every client is looking for generative AI and deep learning or any of these models. Every client is looking towards training, upskilling them towards generative AI. That's the reason where I'm a lot of means like from last 1 year, I'm very busy only on generative AI training. So I'm seeing very less data science trainings and I'm seeing a lot of requirements for me on generative AI most, and generative AI that too using AWS Bedrock or AWS Azure platforms. I'm getting a lot of requirement on generative AI purely. Now we are doing it for, we done overview of AI, ML and all this, like 8 hours lecture for what is that, Mitel Communications. Now we are trying to work on purely generative AI. Why? Their entire projects are on generative AI. So they want their team to build everything on generative AI. Now, in this way, each and every company, they are focusing their money and time, everything on generative AI because of what are all the analytical clients they have it. They are trying to even expand their billing or expand their portfolio towards automation by using generative AI. Getting it, guys? Able to get this? Yes. Now the area of work which we have it. So when you are trying to learn any of this, when you are trying to learn, uh, especially generative AI, there are two ways of learning it. So there are two ways. For example, if I'm going with generative AI, if I want to learn, there are two ways. There is, I'm giving it as a roadmap towards AI. I can directly start learning generative AI without any prior knowledge. I can directly start learning generative AI. Just you need to have a Python knowledge. You need to have Streamlit. You use cloud platforms. You don't need to have any ML and all that, just like you will be having cloud platforms, and you start learning where mostly you are trying to learn within Gen AI, you are trying to learn only prompt and you are able to learn RAG. Only these two different architectures you can do. This is one part of it. So only with this part, getting into a job is a very bit difficult. So who learn it? In simple, people who are already in a company, who are already in an organization, who can give them an opportunity within Gen AI. If they're already in a company, yes, this may work. Now this, I'm doing it for managers, or I'm doing it for 12-year, 15-year folks, I'm doing this training. So they have Python knowledge and we are upskilling them only on generative AI, one level of category. And even in some companies, data analysts who do reporting like Power BI and all that, they are learning. This is one segment I have it. Another segment within generative AI is ML plus generative AI. Now, these are people who already know data science, who are already familiar with data science, and they are trying to learn generative AI. And where these people can perform ML algorithms and they can perform same Python and all the above skills, whichever I quoted here, right? They can do all the skills. They can do all the skills. For example, I can say Gen AI skills. They can do all this ML skills they are having plus Gen AI. Even above ML, you can have any of the skills. You can have SQL, Python, etc. I'm just saying ML algorithm skills. And there is another level of skill. Now, even these guys can do only prompt engineering and RAG. There is another layer of it, ML plus Gen AI. I call it as generative AI in depth, where you are having ML algorithm skills, plus you are having your deep learning skills. So the actual path is going to the deep learning. So now there is another way directly you can jump into Gen AI, but you cannot do all. But going into deep learning, you are learning about neural networks, especially feed forward neural networks. You are learning about TensorFlow. You are learning about Keras. You are learning about PyTorch. You are learning all these different types of libraries. And by learning these libraries, you can perform image recognition. So if the company is asking you to work on image recognition, you can do that. Or you can work on LSTMs. So why LSTMs? In order to understand about your transformers, LSTMs is a bit important element. So you're understanding LSTMs so that you can do forecasting, or you can do text-based analytic as well. We call text analytics. So like NLU, natural language understanding, you can do a very simple generation you can do. And then you are learning about transformers, attention-based models, transformers. You are learning about vision-based Gen AI. And once you completed all this theory part, so like you even developing transformer models using Python and even developing image-based models with Python, once you've done it, so like that is more, you are having a very good knowledge of it. You can build even a small language models. Whatever I said here, you can build SLMs a bit. You can start developing small language models. And within generative AI syllabus, you are able to do prompt engineering. You are able to do RAG. You are able to do fine tuning. You're able to do again, what is that, pre-training. You're able to do any of this. And within this pre-training also, you have approaches like LoRa, like teacher student method. We got LoRa. We got teacher student method, teacher student method. We got reinforcement learning, head optimization. In this way, we have different fine-tuning approaches. So by using any of these approaches also, you are able to make your LLMs to learn better. Now, these are the overall 3 ways which you have it. Now, the best way is completely up to you. Now, if so, like this is a bit theory. There are 2 different ways of learning it. If you directly go for it, it is one advantage. But instead of that, if you are able to go into this layer, there is even more advantage. This is more like an AI profile. This is more like a data scientist plus Gen AI profile. Now that's the reason, even the reason behind showing you this profiles is the same thing. Now if you look at, they are asking TensorFlow, Keras, PyTorch, Pandas, BERT model, which is all comes into your transformer models. Again, if you take this is Virtusa, they are asking about same deep learning. They are asking about your NER, named entity recognition, dependency parsing, co-reference resolution, I think parts of speech tagging, tokenization. And this is from which company? This is from Fractal. This is NLP senior data scientist, NLP, Keras, PyTorch, deep learning skills mostly in that way. So it depends upon how you are trying to pick it. Got it? Clear? I'll be doing that, Dhananjay. Sure. Any doubts? Is it clear, everyone? Any doubts, you can ask me. And these are some of the applications of generative AI. I don't know if you are aware of it, you can. Generative AI. So one is University of Pennsylvania deployed a generative AI model to stimulate spread of COVID-19 and test different interventions. Generating high quality medical images, hospitals can employ generative AI tools to enhance the traditional AI diagnostic abilities. And these technologies can convert poor quality scans into high resolution medical images with great details. And again, a team of researchers experimented with GANs, generative adversarial networks, to extract and enhance features in low quality medical scans, transforming them into high resolution images. And brain MRI scans, everything like image enhancement, we are doing it. And they got MedPalm 2 from Google, which is trained on medical Q&A dataset, and which is trying to provide 85% accuracy rate in order to answer your medical answers, related questions. And again, there is a research happening on protein SGM that can generate novel realistic proteins after studying imagery representations of existing protein structure. Now, deep learning a lot used in DNA sequences in order to generate new drugs, in order to invent new drugs, they are using it. And again, they're using ChatGPT to transcribe and summarize patient consultants, fill this information into the corresponding EHRs. So we know EHRs are your health records. So we call electronic health records, and it is used for clinical documentation. People who are in abroad, they know what exactly health records are. Every patient's information they are storing inside a health record. And apart from it, they are using generative AI without even going to anywhere. You can just change the dresses. You can wear it without even trying it. You can do that, how it looks like on your face. There are various examples of generative AI, and these are the different types of models we call language models. These are the uses. We have text to text models, text to image, text to audio, text to video, text to presentation. Nowadays, all the models we are seeing right now are related to your multimodals. And most of our LLM models are trying to be more towards agents, which are hardly few activities, especially Python, few web development tasks, few coding plus web development. We are able to see a lot of agents are growing towards these two areas. And every LLM model contains, generative models are having a problem with hallucination. And we as generative AI engineers or AI engineers, we are trying to reduce hallucination rates, and we are trying to improve our model performances. So in simple, there is a lot of examples around generative AI where companies are doing it. Even these are some more. Predictive maintenance, they are using generative AI for predictive maintenance. So predictive maintenance, you all are aware of it. What exactly predictive maintenance is? Now, every manufacturing company want to cut down their expenses on predictive maintenance. So what exactly meant by that is, now we all know we have the cars. Now, before even the due date, do you service your car? For example, the due date for your car service is on 2nd October. Do you service it before that? Or you service it after the due date? What you do? You service it 1 month before, 2 months before, 3 months before, 10 days before, or 10 days after. When you service your car, from the due date, before or after? Mostly after. The reason why? We don't want to waste our money on maintenance. Maintenance purpose is what? To be proactive. Before even a failure occurs, you are trying to maintain it so that you're going to have a better, what is that? Means like lifespan of your car. That's the reason they feel whatever the maintenance they are doing, it's a waste of money. So they always do it after. Now, companies, even manufacturing companies, they do it even more early. The reason why they do maintenance of a machinery very early is, if they are trying to start a manufacturing, if it is running for next 48 hours, if there is a breakdown happened, that going to be more expensive than maintenance. That's the reason they are trying to do a regular maintenance. Because of that, a huge amount of expenses are staying on top of the manufacturing company. So in order to reduce it, now they are using generative AI in order to estimate the exact time of your what is that maintenance. And based on that, you are able to get a very good amount of financial savings. For that reason, they are going for it. Again, the same thing. By using predictive maintenance, according to Deloitte, it increases productivity of the manufacturing by 25%, reduces overall breakdown by 70%, and lowers overall maintenance cost by 25%. And it helps manufacturing optimizes operations by interpreting telemeter from equipment and machines to reduce unplanned downtime, gain operating efficiency, and maximize utilizations. In this way, like, there are lots and lots of use cases of your generative AI. So this is customer service automation. We got it in US Steel. We got our generative AI. GE appliances came with generative AI. So this is scribing based generative AI, medical imaging based generative AI, e-commerce based generative AI. There are various examples everywhere. Like companies, what they are investing is on Gen AI in simple. So now, wonderful question, Umar. Now, all our LLM models in simple, or all our image-based models can perform a very good amount of image captioning because of one architecture called as clip architecture. This is a clip architecture. It's a model. It's a pre-trained model, contrastive learning image pre-training. So what exactly they have done inside this data is, they trained or they labeled various images with saying, instead of saying banana, instead of saying a studio, they started writing a text. They gave a caption, a cute banana made from modeling clay, a television studio about to broadcast, a satellite photo of crops and fields, a pup called Rex sitting on a grass. In this way, they started collecting nearly 400 million text to image pairs, which they scrapped it from the internet, and they labeled it, and they developed a model. And by using this model, again, they developed even more images, and this is the very first layer of it. They developed even more bigger algorithms similar to this. They have taken every image and they started writing a captions to it. Now our LLM models can perform a very good captioning on the images than a regular computer vision model. That is the advantage we are able to find it with generative AI. And let me just summarize what exactly we discussed. Now, what exactly a data scientist do? Very simple. You need to know how data scientist is having a benefit or the difference with generative AI. Very simple. Data scientist or a data analyst is trying to work on business decision making. A data scientist or a data analyst purely work on business decision making. Now, a data analyst primarily uses Power BI, SQL, and Python. He's trying to analyze mostly about what, and he's trying to analyze more about why. So like, he's trying to say what happened in the business and why it happened. He's able to provide what, and he's able to provide why it happened. And by using even machine learning, he's able to say about the future. He's able to explain about what gonna happen. So what gonna happen in the future. So even by using machine learning, he's able to explain or help a company to make decisions about the future. And he's able to help the company to say what decisions they made and what are the benefits and why they made it. Now, data scientist is purely working on what? Analytics. So analytic falls into a category of what? You are trying to help a company to grow the business with the help of business decisions. Now, if you look at any of these companies, take in simple, Mu Sigma. If I just go back to Mu Sigma, what is the Title: Data-Driven Decision Science. Now, this entire Mu Sigma, we are a pure play decision science company. The big D is decisions, not data. So now, what exactly this entire Mu Sigma is running around? They are trying to run completely around decision making. Now they are using, so now see this. We believe the purpose of AI, machine learning, and computer vision is to improve decision making and intelligent automation. Now, the first part of it, we are trying to use analytics. Now, data scientists are purely working on only decision making. So every company who is using decision making, yes, they are going for it. Now, the same companies who are doing decision making, healthcare, want a proper decision making in marketing, sales, operations, in finance, and all that. Now, the same healthcare company, they are looking for automations. In the olden days, we are able to do automations with the help of a concept called as RPA. Even right now also we are doing, and RPA are getting pretty much stable now. So we call RPA, robotic process automation. In order to do an activity, if there are 10 steps, just with one step, we are able to automate that process. We call RPA. Now with the help of RPA, we are able to automate it. Now again, let me remove it. And let me just call this automations into two categories. One is process automation. Another one is data-driven automation. Now, in order to perform this process automation, companies used to use RPA, or even if there is a process automation from different websites, I want to collect the data, all this, even we can use a bit of Zapier. This is also a process automation. It is not a data-driven automation. Now I want to perform data-driven automation. What is a data-driven automation? Now I want to automate biometric. Instead of a security guard, automatically a camera need to identify this is our employee, this is not our employee, it's an outsider. I can use computer vision. Or I want to use a chatbot or a generative AI chatbot, Gen AI chatbot, to speak more like a human. So like for that reason, I'm using Gen AI chatbot so that I can remove service department. So again, it is an automation. Or I want to improve the high quality medical images. In order to do that, that is again a cumbersome process. So instead of again shooting them, or in order to get a high quality x-rays and all that, so I'm just using Gen AI to get that. Again, getting a scans is also a kind of automation we are trying to do. So medical scans, I'm just writing. Or I want to go and sell various products within our store. I want to sell various sales. Instead of sales guy, I want to recommend them better sales. Again, I can use Gen AI in order to perform that recommendations. So on chatbot recommendations, I can do it. All this falls into data-driven automations. Now, what companies are expecting is, hey man, if you are already doing analytics, and they are using this existing analytics team in order to work on the areas where there is a very less programming, and where there is a mostly which can be done by a data scientist, they are trying to go for it. So even in a simple note, for a data scientist, the future in lines of technical skills is only automation. After data science, anything future in lines of technical skills is purely automation. For that reason, not process automation. For that reason, what data scientists are doing is, some companies, they're expecting both the skills in one person. I want data science knowledge where you're already having ML. So if you can have Gen AI, you can build RAGs and you can build prompt engineering. In this way, they are expecting means both data science skills and a bit of generative AI skills from the people. Got it. And even most of the clients, they started giving more weightage to generative AI because it's in the current boom. Maybe like for next 2 or 3 years, they start doing all Gen AI work and agents works, and parallelly they do their analytical work. But they give more investment and budget to Gen AI. So companies are giving more focus on generative AI based project work right now. And they're expecting those relevant skills from the candidate. If they have RAG, or if they have prompt engineering, or if they have LangChain skills, or if they are having those tool skills, that's going to be an advantage. Got it? Is it clear, everyone? So the entire data science profile, or in the whatever the data careers we have, the entire data careers can be used only for two, either analytics or automation. Victor, the very first level, even if you ask me, the first layer to get an interest is try to understand the pre-trained models. So you don't need to learn all the underlying math. Means in order to boost yourself, in order to gain the confidence, try to use the pre-trained models, start applying them. Use the skills. So like we do the same thing using Hugging Face, using LangChains, using your Amazon Bedrock, using all this kind of models, and you're doing it. And the second layer of work after that, once you got an interest, you started focusing on the projects. Now the second, you done everything. Now the second layer is automatically you gain the interest in order to go to the theory part of your transformers, and you start doing it. And even though you are learning the theory part of transformers and all that, still there is no that companies who are not developing everything from a scratch. Very few people they are doing it. Okay. Is it clear, everyone? So, William, are you good with ML part or you are new to ML? You are good with ML or you are new with that? Oh, you are working in ML. Now, if you want to go in depth about it, this is the plan. Normally, I follow the same plan. For example, if I go with learning deep learning or then saying Gen AI, my plan goes in this way. I first start with feed forwards, feed forward neural network. Within feed forward neural networks, you have various subtopics and where we try to explore libraries like TensorFlow and Keras. Once we got some good idea about TensorFlow and Keras, something which is more easy for a person, I go for it. And after completion of it, I just try to touch CNN theory plus a project. So where we can work on one computer vision project. So once this part is completed, CNN plus theory, here I try to introduce a concept called as pre-trained models. So here I try to explain the importance of a pre-trained model. Only then they're going to make a sense. So once they got to know about a pre-trained model, then we try to customize this pre-trained model. We are calling transfer learning. I try to teach them. Once this part is completed, then I start using the regular, I go into generative AI syllabus. So before even getting into transformers, just I introduce the theory part of it. So just I start theory part of Gen AI, and then I start going in depth into theory part of transformers. So once I explain transformers in an easy way, they try to understand what are transformers, what are autoencoder models, what are decoder models, what are regressive models, so what are T5 models. Once they are able to understand how we can use these models, and there I start introducing them Hugging Face. And once I start introducing them Hugging Face, I start helping them to how to use these models and how we can perform fine tuning of these models and what are the different ways of we can say model accuracy improvement. I can say model improvement or I can say customization. Model customization. How we can do that? So examples, prompt engineering. Here I introduce them prompt engineering, RAG, fine tuning, and then go with pre-training. And this stages, we try to work on the coding part of fine tuning. We work on coding part of pre-training. Once people are able to grab it, they are able to understand it. Then we get into the prompt engineering part and RAG part, prompt and RAG. So using your regular Gen AI algorithms, using OpenAI, using Llama, using OLAMA, using your Bedrock, and within that there are different models. and using mostly like lang chains, as a framework in order to customize it, and where you learn about vector databases and all that. Once this is completed, then we get into agents within this. Once we completed agents, then once the people are very good with all these areas of prompt engineering, RAG agents, they can do fine tuning, pre-training and all that. Now something which is needed for your regular profile, we are done. Now we will be going into the advanced elements, like we are trying to go in depth about other algorithms like attention based models. We try to go with LSTMs. We try to go with encoder decoder models, E2D. And we try to learn about autoencoders, types of autoencoders, diffusion models, clip architectures. We try to code diffusion models. And once all this stuff are done, then finally we work on a small projects on diffusion models. And last, we will be working on various fine tuning techniques. Fine tuning techniques on like LoRa, teacher student teacher method and all this kind of approaches, and reinforcement head related approaches. And once this fine tuning techniques are completed, then finally we close it with respect to our this one. So working on a bit of reinforcement learning theory. So this is optional. I'm not touching it. Real reinforcement learning and graph-based neural networks. So we no need to touch it, but simply I will be giving an examples of where you can use graph-based neural network, mostly for DNA sequences and all that. People work on graph-based neural networks and reinforcement learning. This is the overall syllabus which I cover it normally. This is the sequence I go. And for regular data scientists, what I do is I'm just going with, I'm not touching all this part, just we are directly touching Gen AI. People who done ML, they directly learn this prompt engineering.